Okay, so let's unpack the absolute heart of pretty much every piece of software we all rely on.
Right.
We're diving into databases today. I mean, they're the single source of truth for everything, whether it's a web app, a mobile game, or a big AI system.
And our mission here isn't just to, define what a database is. It's to really get into why developers treat it like the ultimate source of truth.
Yeah, what makes it so critical?
It all comes down to three fundamental needs, three things that really define a successful application.
Okay, so what's the first one?
Data persistence.
Right. It sounds obvious, but without it, your app basically has no memory. It's like a goldfish.
Exactly. The second it shuts down or crashes, everything is gone. A database ensures that data is stored, permanently and reliably.
And that permanent storage is key.
Yeah.
But it's about more than just remembering, right? It has to be trustworthy.
It has to be. And that's the second piece. Data integrity. Databases have built-in rules constraints, keys that act like bouncers at a club.
To stop bad data from getting in.
Precisely. They stop contradictory or just plain wrong data. It's what prevents things like, say, accidentally double charging a customer.
And all of that, the persistence and the integrity, it all has to happen fast. Really fast.
At lightning speed.
Yeah.
Yeah, we often forget that databases are these highly engineered systems built for performance. It's not just where the data lives, it's how quickly it can find it.
And that's where things like indexing come in.
Absolutely. So we rely on them for reliability and speed, but getting both often depends entirely on which type of database you pick.
Which brings us to the great database divide.
The great divide. Yep.
The classic choice is relational, what people call SQL. We're talking about things like MySQL or PostgreSQL.
And those are all about structure, a very strict schema of tables, rows, columns, and crucially, they follow what we call ACID properties.
AC, can you break that down for us?
It stands for atomicity, consistency, isolation, and durability. But what it means is guaranteed reliability. SQL is the standard for high-stakes use cases like banking systems or big CRM software where you just cannot afford a single mistake.
But doesn't that rigidity, that kind of strictness, trade away some flexibility, maybe development speed?
It absolutely does. And when you need that flexibility and you need to scale massively and quickly, you turn to NoSQL.
Non-relational.
Exactly. These are built for unstructured or, rapidly changing data.
For example, something like MongoDB uses a document approach, right? Which seems great for stuff like user profiles on a social media app.
Perfect for it. Or you have something like Redis, which is a simple key value store. It's incredibly fast for things like caching.
And of course, now there are managed cloud solutions like Amazon RDS that kind of handle all the messy parts for you.
They do, which is a lifesaver. But no matter what you choose, you have to get the design fundamentals right. We already mentioned indexing, but there's also normalization.
Normalization sounds pretty technical. What's the actual impact if a system isn't normalized properly?
It means data redundancy, just rampant duplication.
You're repeating the same information over and over.
All over the place. So if you update a user's address in one spot but forget the three other places it's stored, your whole system just fails to be trustworthy. Normalization cleans all that up.
What's fascinating to me is how the application actually talks to this database. I mean, it's rarely direct anymore, is it?
Almost never. Most modern apps use a middle layer, usually a REST or GraphQL API.
And why the extra step?
Security and modularity. It prevents direct access and lets you strictly control what data goes in and out. This architecture is absolutely fundamental for microservices.
Ah, okay. Where you have dozens of small, independent services instead of one giant application.
Right. And each of those services often manages its own little database.
That's smart. So if one part fails, it doesn't bring the whole thing crashing down.
Exactly. And speaking of modern, nothing screams modern like AI. Databases are the foundation there, too.
In what way?
Well, machine learning models need massive data sets for training. They need to store model metadata, track logs, analyze predictions. That intelligence layer just cannot exist without a rock-solid data foundation underneath it.
Given how vital all this data is, let's talk about the biggest threat. What's the core security issue developers always have to be watching for?
It's always been SQL injection. This is where a malicious user slips a piece of code into a normal input field, like a search box, and tricks the database into running a command it shouldn't.
Like dumping all the usernames.
Or deleting critical data. So vigilance against that is just fundamental for system survival.
So at the end of the day, what this all means is that choosing the right database, designing it well, and securing it, These aren't optional skills.
Not at all. They're the backbone of all reliable software.
Okay, so to wrap up, what's a final thought for our listeners to mull over? Where is this all heading?
I'd say watch the evolution towards serverless databases. When you combine those with AI-optimized query engines, the future isn't just about where data lives, but how intelligently systems can manage performance and scaling on their own without needing constant human intervention.
So the database becomes its own expert.
That's the next frontier.
Yeah.